That's Ladyada.
Hey everybody, and welcome to my desk. It's Ladyada. It's a Sunday evening. It's hacker o'clock, Ladyada o'clock. And I thought we would, spend 15-20 minutes at my desk, and then we have a 15-minute great search as well. And we'll just see what's going on my desk.
We got a lot of cool samples. Let's dive right in.
Okay, so first up, so let's go to my let's go to my computer, and I will go to Adafruit where I'm dealing with. I don't know if you knew, but there's a part shortage.
I've heard.
The LSM6DS33 is a part that we've used. It's a very low-cost IMU. Seen here, it's partnered with a magnetometer. The magnetometer we got in, but the IMU we still can't get. So it's the LSM6DS33. It's discontinued. It was a very inexpensive, low cost, but fairly good quality IMU. So it was good for like basic sensing because IMUs can easily get into like $6-7 range. And this one was like a couple bucks. So I really liked it, and it is featured in a couple of things. First off, of course, we've got 2 breakouts, but it also made it into the Feather Sense. Has this chip here, the LSM6DS33. I don't know if it's listed here. I think we just say an IMU, but it's a Excel gyro for the IMU, and then also the clue, which we do have some left over in stock. This one also has the Excel gyro, but then we can't get it anymore. So looking at other IMUs, I found that I could get an ST. ST doesn't make the LSM6DS33, but they do make the LSM6DS3, and they make a couple different versions, including one called the 3TRC. I don't know what the C is, but it's basically an entry-level, low-cost IMU, which is perfect because, again, I can get a really high-quality IMU, like the ISM33, 330 is in stock, but it's like $6-7, and it would basically double the bill of materials cost for something like the Feather Sense, which is supposed to be inexpensive, or the Clue, which likewise, I want to keep it inexpensive. So I picked up some of the LSM. So this is the D-SOX, and let's just look at the front. So the what is nice is ST decided, like, basically every IMU after the DS33, they're like, okay, we're going to do this kind of standard QFN, DFN with, I think it's 3 pins on the top, 4 pins on the side, and it's kind of rectangular. But they've kept the same pin out. So if we go to the overhead, it's a little bit clunky here. This is actually an LSM6D SOX breakout, but I removed the 6D SOX and I soldered on the DTR, which I've got here. Sorry, this one. The LSM6 DS3TR. See? And, the register map did change a little bit. I will notice, all these chips, they're pin compatible. But, registers, things will move around a little bit. That said, I did get it working. So going back to the computer, I've got, my Arduino working here, and you can see it's got temperature, accelerometer, and gyro data coming out, and it's just fine. So, and I've got potentiometer working, and I got the shake, motion detection working, which is pretty much all I used the LSM6DS33 for. So I do have to do a board respin for the Feather Sense and the Clue, but the good news is that this sensor is available. So, what I'm going to do is I'm just going to purchase basically 2 years worth because I know I'm going to use them, and I know that this is just part shortage isn't ending. So I might as well get a year or two's worth of this chip so I can keep the Feather Sense in stock and the Clue in stock, and also I'll revise those 2 basic breakouts so I can have a low cost IMU breakout. One thing that's interesting is as I was looking, because I went to st.com, and I think I looked for, I don't know if it's under sensors, MEMS sensors, and then I think I looked at iNemo, which is what they call their gyro accelerometers. So one thing that was interesting about this is everybody's favorite, hold on, 9DOF sensor, the LSM 9DS1, is, I don't know if you can see, it's very small text, but it says, and it's like, hi, I want to resize your screen. It says NRND on there. So, if you're using the LSM 9DS1, I know that Arduino using a couple boards. I know other people have used it. It's adorable because it's like a 9DOF IMU and it's all in one, and it was pretty inexpensive. It was a couple dollars. It's basically being discontinued. So, thankfully, I didn't use the 9DS1 of these designs. So it's like I'm only changing out one part and the part's changing to something similar. But it is kind of a downer. Anyway, so I ended up looking through here for what was available. The only thing that's a little annoying about ST's part selection site is they don't let you search for pricing, whereas I will say TI is really nice. They'll give you budgetary pricing. Budgetary pricing isn't the actual pricing. It's always going to be a little bit less, but at least gives you an idea, like, is this about $1? Is it about $2? So I had to look up each one of these chips to see, like, how much did it really cost. And that's how we, ended up with the LSM6DS TR. So, it's a revision party always here, but, thankfully got this firmware going. So I feel confident I'm going to spin the clue, going to spin the feather. Since luckily this new sensor is smaller, so, I'll just, space will just change a little bit, but the firmware should be very minimal, and thankfully you can detect which one you have by reading there's a Who Am I register, and it gives you different values, so you'll be able to know which sensor you've got. So I've seen this in a bunch of different boards that have sensors. They're kind of constantly swapping them around. So that's the LSM 6DS33 swap out. And then the reason I was actually kind of forced to do this is I wanted to, they're revising the Feather Sense, but then Scott also was like, oh, it'd be really useful to have a NRF52 feather with a TFT on top, like the ESP feather that, we have and made. It's like, got the TFT on top, and on the bottom there's the ESP32 S2 or S3. And I was like, oh yeah, the NRF52 module is much smaller. And there's even a little bit of space, so I thought I would also put some sensor pads down. So this kind of forced me to okay, I gotta swap out the IMU for that LSM6DS chip because I wanted to put an IMU here, and I was like, well, now I'm I have to get it together and do the swap out. So this will end up revising 6 different boards, much like the CP2104 to 2102N. It's just kind of life, sensors and chips. I'm noticing that it's not just that you can't get certain parts, but there's an acceleration of if it was going to be end of line, the end of line just comes much faster. And if it does get end of line, you're not going to be able to necessarily do a last time buy. So everything is just much more sped up. Okay, what else did I say I was going to show people?
Well, we have samples that I did a little bit of a preview on our Twitters. It's the filament stuff.
Yeah.
And
did you want to do chip shortage? We can do that later.
No.
Right. Sorry. Correct.
No. Can do it.
No. Yes. Let's show some filament samples instead.
Yeah.
It's been a day. Let me get my samples.
Yeah.
And
we're gonna do chip shortage this week on Ask an Engineer, so we'll just do the one that you sent me this week.
Yeah, that's cool. Okay,
so that's done in advance.
Yeah. It's
yeah,
all
let's
done.
do that.
Don't worry. There's always no parts.
Yeah.
Okay.
Yeah, no parts is still a true statement. Okay.
Okay, so let's go to the overhead and we'll check out these cool filaments. So I got. What's funny is I've been trying to get filaments for literally years. We actually got some LED filaments. Literally 5-6 years ago, but they were 70 volts, and I was about to put them in the store in the last minute. I just said nobody's going to want to deal with these 70 volt filaments. So I paused. But then I found a supplier that would sell me a small quantity of 3-volt filaments, and I was like, that's what I'm talking about. So these are kind of neat. These are, they look like spaghetti noodles, but they're actually LED. There's a ladder of, hold on, let me get some wires. Wires are good. Let's get a power wire here and a ground wire. And we'll just, they can run off of 3 volts, which I really like. So what's interesting is that if you look, you're not going to be able to see it very well here at all. But on the back, there's like this little ladder of a very thin metal piece and LED diodes that are bonded on. And then I think the side with the hole is negative. No, the side with the hole is positive. That's what I meant to say. Okay, so this, for example, is a pink color, and you see you get a really nice, smooth color effect. I'll hold it up here so people can see what it looks like. Not blown out as much. Yeah. So there is, if you look really closely, there is a slight, dotting to it, but you have to be really close to see it. It's definitely like 1 LED per millimeter, maybe one every 1.5 millimeters. And what's really nice is that it's really flexible. I mean, it's, you can pretty much move it just like EL wire. Or it's even more flexible than EL wire, and it's got that full color to it. It's a much more solid and doesn't have the buzzing sound, and you don't need an inverter. So for small illumination or decoration, I think LED filaments are kind of neat. Okay, so this one is green, and now I know the side with the hole is positive. Okay, so this is like a cool lime green color. Again, very flexible. I haven't really been able to break them, although I haven't really tried. I think if you really pinch them a lot, maybe you could break them. But they seem very, very durable. So great for wearables or cosplay. If you wanted to have a cool neon strip that's very thin and doesn't use the LED neon. So that's good. And I got a couple other colors. So I showed pink and green. I think this is blue. See. And then, yes, this is the blue also. And these are all about 30, so it's about a foot long, about 30 centimeters. And then lastly, I'll show off the warm white because I feel like that's kind of that's what people want to see. Or maybe this is yellow. Okay. This side's got the hole. And these are used for, yes, this is like a warm white light. So these are used for, when they make LED light bulbs that have funky, like Edison bulb shapes, but they want to fake it. They just use this and they wind it through to get that cool, Edison lamp effect.
Okay, let's do I got a question about the filament, and then we'll do a general question after you show these things off. No, you can't use it outside. The LED filament is not outdoor suitable.
It's not outdoor suitable.
You could put it in something that is weatherproof, but
it's not designed. I mean,
it itself is not.
Well, it'll work for outside, but only I wouldn't recommend it for more than a half an hour.
The answer is no, because if we say, well, you could, then someone will put it underwater.
Yeah, they always do that. People always
can the filaments be cut to shorter lengths?
Not really. I mean, I think if you were skilled and you were comfortable with it, you could cut it and then scrape off the rubber, and you might be able to solder to or bond to the metal, but pretty much no.
I think we'll just carry lots of different.
Yeah, it pretty much.
If anyone has any naming ideas, we want to have a catchier name than just the part number and stuff. So
yeah,
we'll try to think of something.
And this is a non-flexible type. But the trade-off is it's much, much brighter. So this is actually you could light up a room with it. It's not super bright, but you could, it would be it's reading light, bright, and it's got two. I think it's got 2 layers of LEDs, one on each side, because there's no dimmer side.
Suggestion is magic wire.
Magic wire. Okay, so that's the filaments.
All right.
And there's other colors.
Okay.
There's orange and like.
Do you want to show some more stuff, or do you want to answer some of these more general questions?
Can you see if there? What else I said I would show off?
I don't remember.
Okay, well let's just let's answer the questions and then I'll show.
So I can help out with this.
Yeah.
Both of them. Chip shortage question: how long do you expect a Raspberry Pi shortage to last? In response to what you thought was just the way it's going to be now. So.
Just the way it's going to be now.
Yeah. So my prediction is we're not going to see. I can order a Raspberry Pi anytime I want. It just gets here overnight for at least a year. That's our current prediction, just based on how everything is so delayed for so many things that you just can't predict what's going to happen. And so it looks like just, someone has to make a guess, so that's our guess. And then the other question is, can you talk about how the part shortage has affected your future planning beyond current shortages? I anticipate things have changed enough that procurement philosophy has changed and it isn't going back. Yes. So one of the things that we used to do was we used to design for manufacturing. So Lemoore sits 30 feet from the pick and place and the oven and all the things that we use to build and test things. Now we are designing for purchasing. So the difference is we look at what is possibly available, how long the lead times are, how much stuff we have. And while you did planning like that in the past, there was never like, well, if I need 10 things to make a product and one of them's gone, I'll be able to get that other one part soon. That's not how it is now.
Yeah.
So we have to redesign, we have to do lots of revisions, and we have to design backwards from availability. If something
it's not what I want to work on or what is interesting to me. It's like what I can get. Because there's chips that I really was interested in looking at, and I just can't get them. So it's like instead of just saying like, this sucks, I can't work on it, and just complaining, I'm like, well, what can I work on? And so, for example, I can get Espressif modules. Espressif's been really good about getting me chips. And so it's like you're seeing a lot of ESP boards because I can get ESP chips, and I can get ESP modules, and so I'm just going to keep doing boards with what I can get. I'm not going to come out with, I took a break from doing Trinkies because it's just very hard to secure SAMD21s. Like, even when I order them, they don't ship.
Yeah.
So, or like the dates, one thing that's definitely happened more, it's like I'll order something and the date gets bumped and bumped and bumped and bumped. And so, I can sometimes get samples of parts, but then, I don't. I'd have a policy for like a new product. I haven't really purchased a new component early, if that makes sense. It's like if I only have a sample, I don't, because it's so unclear when I'm going to get it. I wait. I actually tell the company, tell me when you can ship it to me and I'll book it. I'm not going to future order parts that I don't already have sales predictions for because I'm just going to get screwed. So instead, I just wait until that part's available.
Okay.
And like I do see like parts come in. Like there's this tide that comes in and like, oh hey, like that sensor is like suddenly available now. And then like the tide will go out and then tide will come in and be like, ooh, this like chip is available. It's not everything is available at the same time, but I do see like the NAU 7802, which was a breakout we put in a couple weeks ago. Like, I designed that years ago, and it was just not available. But, like, now you can get it everywhere. Like, they really did make, a couple 100,000, and they kind of seeded the market with them. But, for 2 years, you couldn't get it. So it's just when the number comes up.
Yeah, and, one of the things that we've learned is you just have to be endlessly adaptable when you're in the technology world, and more so than ever. There was a lot of times where things were easy. You could do a Kickstarter and, when the time it's funded, I'll just get all the parts and I'll do it now. You just have to have quite a bit of insight and be prepared to take some really creative risks on which direction you're going, and also have lots of contingency plans.
Yeah, in the last week, Phil and I were chatting. 4 different companies dropped manufacturing lines.
Yeah,
completely.
they're like, we're done.
They're like, this thing that you actually sold quite a few of, we are not making anymore, and we're done. And they're from one-person maker companies to multi-billion-dollar companies that just said, we just can't deal with this anymore. And I'm like, this product was pretty popular. And they're like, we just can't it's just not, I don't want to put words in their mouths because I don't know what they're thinking, but like reading between the lines, it sounds like it's just not worth it to stress and bust your ass and manage all the inventory, and then you still can't get the last component. So they're just focusing on, if it wasn't their most popular product, their most profitable product, they pretty much have.
Well, the other thing is, we've diversified for years because we didn't want to be stuck with one particular chipset. We didn't want to get stuck with one particular programming language for microcontrollers. And so I think sometimes folks are like, oh, why don't you just do one thing? Commit to one chip line, commit to one, only Arduino, or commit to only SAMD. And I'm glad we didn't, because we've been able to zig and zag as things have changed. And the one thing that's for sure, so we don't know when Raspberry Pis will be instantly available, but I can tell you one thing for sure: change is coming. Everything's going to constantly be changing.
If you need a project that has multiple Raspberry Pis,
but
probably you might want to think of other projects that you've been putting off, because I'm sure you have a big bin of projects that you haven't finished.
But everything's going to keep changing. Go back to those. and that's just like how progress in life goes. Like there's scarcity and there's surplus, and there's surplus for some things and scarcity for others, and you just have to be financially and mentally prepared and have a culture at your company that's like, okay, we're just going to roll with it. We're going to surf these waves, build better boards, and hang out with cool surfers.
Okay. Well, we're running out of time, so let's just show this one switch sample I got.
It's a long answer.
JP wanted us to stock these. These are like using some, I think like 808 synths or something. There's a LED that's separate than the button, but I just connected them together with some wires. And I got these gray with red, and then, red with red, and then black with red. So I might carry, these three colors. He wanted to make like a synth keyboard. So I thought it would be kind of cute. Okay, so let's go on to research.
Where in the world is that part I need? The Great Search with Digi-Key.
Every single week, ladies, user hours of engineering and more to search on Digi-Key.com. Thank you, Digi-Key, for the parts that you're looking for. This is a great search, Ladyada. What are you looking for this week?
A common request. We have people who have emailed us multiple times, and they said, I want to pick up a low-cost oscilloscope, my first oscilloscope, and they want some suggestions, and I was like, oh, I don't really have a good suggestion. I haven't looked at what's available in the market. I thought I would use that for the great search, check out Digi-Key, see if there's a couple good options available, and also talk about some of the trade-offs. Basically, if you have infinite money, you can get the best scope in the world, but if you don't have infinite money, let's say your budget's like $500, which I think is pretty fair for a good desktop scope, you do have to trade off what you're willing to spend money on and what you're willing to let go of in order to get other specs that are better, because it's all going to be, all the specs are going to be, they're going to affect the price. The more bandwidth, the more expensive. The more channels, the more expensive. The bigger screen, the more expensive. So what's important to you? So it's a trade-off. Again, if you have $5,000, you probably don't have to trade off any of these things. You get exactly what you want. But for $500, let's see what's available. So let me go to, I was going to do a great search about IMUs, but there are no IMUs, so it was a total downer. Maybe when there's more available. Okay, so we're at Digi-Key. Let's go to the computer. And we're going to type in oscilloscope, which is tough to spell. But they do have them. I think I got my first oscilloscope from Digi-Key as well. So there's a couple scopes. There's the standard type scope, and there's also these smartphone tablet scopes. Now, I'm biased. You will get a higher spec'd scope if you don't have a screen, but I really, really, really like the benchtop ones with the screen. There's some people who can do the USB ones. I just don't like them. It's personal. I just don't like them. Other people can do a video where they say how much they love them. I really like to have the knob. I like to be able to see the waveform, and I'm twisting the knob at the same time. I don't necessarily like computer style. So that said, let's just do basic. First off, I want bench type. I want it to be active, and I'm only going to look at ones that are in stock right now, because I'm not going to suggest a scope that you can't get. So again, there's going to be a lot of trade-offs. So the things that I find most important in an oscilloscope is, number one, the number of channels, because that's, there's no upgrading. It's like once you get the channels, that's fixed. You pay more for more channels. There's basically either 2-channel or 4-channel. Those are your options. Now, I have 4-channel scope, and I've always kind of purchased 4-channel scopes, but I'll say, 99% of the time, I don't use 4 channels. I use 2 channels. There's a trigger, and there's a response, especially if you're doing analog. But even with digital, because instead you'd get a logic analyzer that you would use for your digital signals. And part of the reason for that, of course, is digital signals are usually much, much faster than analog signals, like ironically. It's not unusual to have a microcontroller that is running the SPI line at 60 megahertz, 80 megahertz. ESP32 can do that. The Raspberry Pi can do that. Sometimes you're looking at a crystal, but usually crystals aren't that fast. Usually crystals are like, if you're looking at oscillation on your analog scope, it's going to be 12 or 24 megahertz. So, if you have a logic analyzer, you can get away with a 2-channel scope. If you don't, there have been times where I'm like, want to look at the chip select line, the data clock line, and whatever, some other line. It's possible, or I want to look at the power supply voltage while I'm also looking at I squared C. So it is possible that you'll need 4. I'm going to assume, however, that you're going to want 2, but you definitely want not 1. 1 channel is kind of useless in my opinion. I think you really need 2. So let's look at the 2-channel scopes. Next up, the next thing you're going to pay for is bandwidth. Bandwidth is kind of sort of the fastest signal you can look at. It's a little bit more complicated than that, because if you're looking at a square wave, the square wave, you're like, oh, it's a 50 megahertz square wave, but the square wave has higher frequency components that will not come through, and so you'll kind of get a sinusoid instead. Again, if you have a logic analyzer, you could probably get away with a slower scope. However, I really think that 100 megahertz is like kind of the minimum. I did look at this, and there were scopes that had a 60 megahertz bandwidth. I think if you want to last a couple years, get 100. It's not just how fast is the frequency of the thing. It's how good is it going to be at reproducing rise times. And if you're doing, if you're looking at some digital signals, you might need to look at, skew or slew rate. It's not a bad idea. So, I definitely 20 is too small. 20 is like a handheld thing. I'd say, 70 plus is good. For a beginner scope, you're probably going to get about like 100-ish. My desktop scope here is, it's 5 gigahertz, 5 gigasamples per second, 1 gigahertz bandwidth. But it's also a very fancy scope, so what you gonna do. But it wasn't my beginner scope. My beginner scope was 100 megahertz bandwidth. There was a TDS, Tektronix TDS 2014, I think, which was 100 megahertz 4-channel color scope. The good news is that pretty much every scope is LCD, so that's nice. They're going to be lightweight. You're going to be able to carry it. You can put it on your desk. You can't search by price, but you can sort by price. So since we have a budget of about $500, I did that. And there are a couple good options. So there's quite a few on the, right under $500 range. Here's another thing, and in addition to bandwidth, memory size. So if you're zooming into, or you want to scan through a waveform, memory size is going to be something that comes up. It seemed to me while looking at these options that there's kind of like either 20 kilopoints or like a megapoint and higher. I actually kind of feel like you could save a lot of money on lower kilopoint memory, but I actually have been really annoyed. I remember once I used a scope with very low kilopoint memory, and it was really annoying because I couldn't trigger something and then look later at the signal, or it was like you couldn't zoom in. There's something nice about you trigger on a signal and you zoom in and you're like, ooh, I can like keep zooming in and I can get the detail, even if you looked at the longer signal first. You triggered on the longer signal and you zoomed in. So even though there's these cheapy, like $300 scopes, I'm going to say, like, get at least a megapoint. I don't care about the interface as much. I've never used Ethernet or USB or Wi-Fi. At the most, I've used, like, grab a screenshot. But everything has a screenshot capability these days. That's not a big deal. And, of course, phones are really good. And with an LCD, you can just take a photo with your phone. I know it's a little tacky, but there's no real reason. So there were a couple options here, and I didn't look at why the why and which. They're all kind of the same family. These ON SDS 7 series. It looked like what you're paying for basically is bandwidth at this point because we selected a range. So 100, 70, 70, 100, 200. If you're really up to about $500, this 200 megahertz, 10 megapoint one is pretty good. So like the 7202, has a big screen. It's only 2-channel, but it is under. You'll get it for $500, and it's got a gigasample per second and 200 megahertz. That'll last you quite a bit. You get this in college or something, and you'll be using it, easily for 5-6 years. And I've seen people use these scopes. The only other thing that you don't really get to know from specs, just purchasing, and why it's good if you can find someone with the same family of scope or the same model, is how good it is at triggering. I've always liked the tech scope triggering. I found it's really solid. It's very reliable. I remember a long time ago, Regal scopes did not have very good triggering, but I think that's probably improved. That was like 10 years ago. I think probably it's a lot better. But if you do have somebody with one of these scopes, you'll put on a signal where you want to trigger on something and look at, is it stable or is it kind of like freaky? Can you do single shot and like it'll actually get the single shot? But as for actual capabilities, pretty much every scope has the same capabilities these days. You can always, have triggers, and you can have, measurements on screen, and you can do math, and you can do FFT. That's super, super standard. So this would be, I think, a good 2-channel scope for beginner, under $500. And then they also have a 4-channel one. It's like $650. I think if you can spare the extra $200, go for the 4-channel. It'll definitely make you very happy. But I think this 2-channel scope is a good beginner scope that will also take you pretty far. So assuming you continue to be interested in electronics, you'll be able to use this for almost everything.
All right, that's a great search.
Where in the world is that part I need? The great search with Digi-Key.
Okay, so that's our show for tonight. One question that came up is a TDS 2014 a good one to buy used?
I wouldn't get one used. Honestly, they're really old at this point. Any tech scope used is probably good. I will say that I had to stop using my TDS 2014 because the controls literally started falling apart because I used it so much that the main channel, the rotary encoder, was really flaky. I know I could have fixed it, but I ended up I need to update this anyways because the screen was quite small. It was kind of a passive matrix LCD, passive E, like it was not like IPS. It was a pretty small screen, and they're much better scopes these days.
Okay.
Used is fine. If you're going to get used, I would get like a tech scope or LaCroix. You're better off getting a used high quality scope. I would not get a used Regal or ON. I don't really trust the used market for those. I'd get a used high quality scope, especially since there are authorized resellers that you can get, so you can get a good scope.
Next up, and how does it work when it's 200 megahertz but 1 gigasample a second? I expected 20 millisecond samples or 40. Shannon,
no, it's not the same.
Does the analog limit it to 200
there's
something?
the internal analog front end, which has a bandwidth limitation, and there's how many samples per second. It's not yeah, in theory, you have like a Nyquist rate of 2, but you can't actually reproduce the frequency. You'd have a much higher sample rate, and also usually the sample rate is shared between both channels.
Okay, and then internally we're going to start to think of names for those filaments. So here's some of the ones that came in.
Sure.
Magic wire.
Magic.
Spaghetti LED.
Spaghetti.
Spaghetti. Light emitting spaghetti. Do not eat. Glowworms. Filament. Haha. Filament. And
your name, Phil, or
yeah, and then the current one that looks like there's some folks that like it is Ada's Lovelaces.
Ada's Lovelaces. That's funny.
You
You could make them into laces. I mean, they would. I wouldn't use them to hold the shoes together.
Lovelaces is pretty cool. We'll probably weave them into a pair of shoes to take a photo because that'll just look cool.
Yeah, we gave them to a friend who does. She does hair design. She's like, oh, this would be a cool hair thing.
So keep them coming if you want to.
Thank you.
Put it into the name machine. And thank you so much, everybody. We very much appreciate it. We'll see everybody during the week. We're very thankful that y'all continue to watch our shows and you support us as a company. There's a bunch of topsy-turvy times ahead, but we're in it together. And we thank you for being part of this journey with us. So we'll see you next week.
Bye, everybody.